Let us see the mechanism of creep in concrete. So, what is actually happening or what is actually leading to the creep in the concrete? So, there is some research being done. We have not established a final theory still yet. Okay, so it is being done. The study is being still carried out to understand the mechanism of creep in concrete. What is happening beside this? But during this study, we have come to one important conclusion that this gel structure of cement paste is actually playing an important role in the development of creep or in this phenomenon. And let us discuss one of the most, of course, the theories that are most convincing and experimentally support are more convincing. Okay, let us look into one of those theories which is most satisfactory in explaining the creep phenomenon. Okay, so let me just give you a little bit idea before going in the theory here. So we know that when cement is mixed with water or water is added to the cement, there is a reaction that is happening between the cement and water, and that is what we call hydration. See, this hydration is nothing but the complete reaction of the cement particle with the water. See, sometimes if water is added than the required, more than the water required for hydration, what happens is, even though the complete cement has got hydrated, still there is some water is going to be left out, isn't it right? Atlani, if you add less water, you will not the concrete will not have sufficient amount of water to hydrate cement. Okay, so this is an issue here. So we generally add more water than what is necessary for the హైడ్రేషన్కి అవసరమైన దానికన్నా ఇంకా ఎక్కువే మనం వాటర్ని యాడ్ చేస్తాం ఇప్పుడు. ఓకే, సో నా వాట్ హ్యాపెన్స్ ఈస్, సో సిమెంట్ పార్టికల్ ఇట్లా ఉంది, దేర్ ఇస్ సిమెంట్ పార్టికల్ హియర్, దేర్ ఈస్ వాటర్ సరౌండింగ్ దిస్ పార్టికల్. సో ది వాటర్ స్టార్ట్స్ రియాక్టింగ్ విత్ ది సిమెంట్ పార్టికల్ ఫ్రమ్ ది అవుట్ సైడ్, right? First the outer surface of the cement particle gets hydrated and it goes inner and inner. It takes certain amount of time, right? See, this hydration process do not just happen at a particular instant of time. It takes certain time. That is what we have said. So when the water keeps on reacting with cement particle, gel is going to be produced, CSH gel. Okay, and of course there are various other compounds also along with CSHL. Together you can simply call that as a gel. So at an instant of time, you have some unhydrated cement, ఇంకా హైడ్రేట్ అవ్వలేదు, హైడ్రేట్ అవుతుంది అన్న సిమెంట్ పార్టికల్ ఉంటుంది. అండ్ అట్ ది సేమ్ టైమ్ there is an already hydrated cement which is in the state of gel, and you have amount of water still left. But what happens after some time, the unhydrated cement completely gets hydrated, so you are going to have gel, and the amount of water that is left, just extra amount of water that is left. Okay, so now this water which we are calling here is going to exist in three ways, that is as gel water, capillary water, and the other one is chemically bonded water. Okay, it is chemically bonded with the compound. So we are saying CSH gels, right? This compound itself has H2O, which is chemically bonded. So water is going to exist chemically bonded, or it is going to be existing in the capillary cavities as capillary water, and gel pores lo gel water kinda untundi water. Okay, no problem. So due to hydration, more and more gel is going to be formed, which results in reduction of unhydrated cement and capillary cavities. Initially gel pores have gel water, and capillary cavities may or may not contain water. If the water that you have added initially is more, it going to contain water. If there is no water, these capillary pores going to contain air, and presence of air in capillary cavities is a kind of dangerous thing to the concrete durability and concrete strength. Okay, so what is happening here is this water which is present in the gel pores and capillary pores is present in the complete gel, isn't it? The paste, in the gel paste. Okay, so what happens is this gel is going to get hardened after a certain amount of time, right? The CSA gel will get hardened and will be responsible for the strength of concrete. So what happens to the gel pores and gel water inside them, or capillary pores and capillary? They are going to get entrapped inside the hardened gel. So there is going to be water inside those gel pores and capillary pores inside that hardened CSA gel. And what's going to happen here is the movement of water held in gel and paste structure takes place under the influence of sustained load. So what we are saying is when we are applying a certain kind of load on the concrete body, and we are leaving that force or the load on the concrete, due to that sustained load, what is happening is the water which is present inside these gel pores is going to move outward, because load, you are applying load, there is an internal pressure developed inside it. So now the water tries to escape from it, it tries to go out from there. So what happens is, until that point, gel pores are occupied with water, and now as the water is going out, what happens to the gel pores? They're going to be compressed. So when they are going to be compressed, what happens to the overall volume of the overall dimensions of the concrete? The dimension is going to decrease, it is going to get compressed, because inside there is a water which occupies certain volume, isn't it, right? See here, there is a concrete here, inside there is a, of course, a pores are very small in size. Of course, this is a representation figure. So this, let us consider this is as a pore, and when force is acting, this pore tries to, the water tries to come out of this, and when it is coming, this pore is going to be compressed, and what happens is there is going to be a little change in the dimensions of the structure, I mean body, concrete body. So that is actually responsible for the creep. That is what this theory is saying. Okay, so this is saying that collided particles slide against each other to readjust their position, displacing the water held in the gel pores and capillary cavities and intercrystalline spaces. Okay, so when this force is acting, see, this is a particle and this is the particle, gel particle, and what colloidal particles, and what is happening is this water is trying to escape from it. It is coming out. And this intercrystalline water is the water present between the particle to particle. So this flow of gel and the consequent displacement of water is responsible for the complex deformation and creep of concrete. So as this water is coming out, as it is moving away from its original location, that leads to the rearrangement of the internal structure, isn't it, right? It readjusts, the concrete readjusts when something is going out. Okay, so creep always takes place only under the stress. If there is no force acting on that body or stress, the water inside the gel pores is not going to go anywhere. So creep is going to take place when there is a movement of water, and movement of water is going to be there only when there is a stress. But you can say that creep is only seen when there is a stress or sustained load. So under sustained stress or load, with the time, the gel, the adsorbed water layer, the water held in the gel pores and capillary pores yields, flow and readjust themselves, which behavior is termed as creep in our concrete technology. In the next video, we are going to discuss about factors that are affecting the creep in concrete. Thank you.